If you've ever shopped at Biedronka, you might be wondering what happens to all those carton boxes in which the products are stored. Products such as fruit and vegetables, sweets and ready-made soups. Each store uses many such boxes. They're placed in a special container and then transferred to the back of the store, where a baler compresses the waste paper and prepares it for transport. Where does it go? What happens to it next? That's the subject of today's episode. Used carton boxes are a valuable material that can be successfully used to manufacture new packaging. For this reason, they're collected and processed as recycled paper in specialist plants.
Współpracujemy z większością sieci spożywczych w Polsce. Natomiast Biedronka jest pierwszą siecią, z którą realizujemy gospodarkę obiegu zamkniętego opakowań tekturowych. Jest to możliwe dzięki własnej papierni, fabrykom produkującym opakowania z tektury falistej i jednostce zajmującym się pozyskiwaniem i odbiorem makulatury.
Bales of compressed carton boxes are brought from Biedronka stores to the chain's warehouses, from where they are transported to the Mondi paper mill in Świecie. Here, they are first delivered to the recycling plant, where over 1 million tons of waste paper from Poland and many other European countries are collected every year.
Nieprzerwanie od ponad 15 lat makulatura generowana w sieci Biedronka trafia do naszego zakładu w Świeciu, gdzie jest poddawana recyklingowi. Współpraca jest systematycznie rozszerzana. Dziś śledzimy i jesteśmy w stanie otworzyć drogę każdej tony materiału, który do nas trafia, od załadunku w lokalizacji sieci do podania na linię produkcyjną produkcji papieru.
From the recycling plant, the bales are transferred onto conveyors, and so begins the automated production process. The wire used to wrap the bales is cut, and the loose waste paper is transported for disintegration. What about the wire? The braided wire is removed together with other impurities. In the disintegrator, the board is shredded to form a suspension from which impurities such as leftover wire, rope, string and pieces of plastic are also removed. Larger impurities settle at the bottom of the machine. They're later transferred to specialist companies for processing. The cellulose fibers are mechanically separated from other substances. From the disintegrator, the suspension is transferred to a buffer tank and then to second and third level sorters. Now, everything goes like the wind. Literally, in so-called hydrocyclones, a powerful vortex is created to remove sand and other inorganic particles. The liquid mass is fractionated into long and short fibers. After necessary thickening, the short fiber fraction is ready to be transported to a paper machine and is transferred to a storage tower. The long fiber fraction requires further processing in sorters and dispersing machines. Let's take a look at the control room. It's here that the production process is controlled and the parameters of the huge paper machine are monitored. This machine has a capacity of 1,600 running meters of paper per minute. Why is such speed necessary? The raw material for this process consists of very delicate fibers, which must be turned into the finished product as quickly as possible. First, they are formed and dewatered, and next, they're transferred onto the sieves of the paper machine. The web is routed to the forming section, and then to 3 presses, which squeeze the remaining water out of it. Later, there's a drying section, after which the material undergoes scanning tests and is strengthened by gluing. This is a wet process, so the web has to be dried again. Then, the paper is wound to form a so-called tambour roll, an enormous roll that can weigh up to 100 tons and be up to 120 kilometers long. The tambour roll is then transported on rails to a slitter rewinder, where it is sliced into smaller portions, weighed and labeled. Finally, it's delivered to a fully automated warehouse. The paper machine produces over 500,000 tons of paper each year. Now we have the raw material, it's time to see how the soup trays are manufactured. This process also takes place at Mondi's facilities. The board is made using a special machine called a corrugator. Individual layers of corrugated board are formed from paper. First, the inner corrugated layer, which gives its name to this type of board, is formed. Then, the outer layers are glued on. The board produced this way is dried on a heating table. Slitters cut the board into sheets, the dimensions of which depend on the given order. The board is then conditioned to stabilize its parameters, such as temperature and humidity. This process takes at least 3 hours. Next, the board is fed onto the production line, where the machine cuts out flat blanks. From the Mondi factory, the flat blanks are delivered to the Geronimo Martin's Polska soup production plant in Brewinów. Here, in the carton packing hall, we see how the machine folds the secondary packaging for the soups, up to 30 items per minute. Meanwhile, portions of soup weighing 450 grams each are poured into the plastic cups. Each cup is then heat-sealed and its production date is laser printed on the cover. Next, it needs to pass through a detector to check for possible contaminants before being weighed and placed in a cooling tunnel for 90 minutes. Finally, we reach the hall where the soups are packed into the secondary packaging. They're transported on conveyors to stations where workers put them into boxes. The boxes are delivered to Biedronka stores all over Poland. Once they are emptied and taken to the back of a store, they are then transported to the Mondi paper mill and the whole process starts all over again. Closed-loop secondary packaging for soups is a solution with many advantages. The biggest of these include 192 trees saved from being cut down each year, 30% less water used in paper production, and a 14% reduction in carbon emissions.